Hello. This is question 3 of the Newton law of cooling. The formula of solving this question is written, which Tm is the temperature of the room. T is the times, and To is the temperature of the thermometer, and K is the constant. So plugging the number into this formula is when at 12 p.m. a thermometer reads 10 Fahrenheit is placed in a room where the temperature is 70 Fahrenheit. It reads 56 when it's placed outside where the temperature is 5 Fahrenheit at 12:03. What does it read at 12:05 p.m.? So first, for the first sentence, we set the times as 0 because it starts at 12 p.m. and the TO is what's the temperature the router read is 10 Fahrenheit. And at that time, the room temperature is 70 Fahrenheit. So we could write the equation as T equals 70 plus parentheses of 10 minus 70 e to the negative k, which is
Okay, after we set up the equation, we have to simplify the following. So we have now 72 plus minus 60 multiplied by the exponent of negative k, the time value. Now we have to replace the t in the time with our initial values, which is the time is 3 minutes. 3 minutes, and during these 3 minutes, the temperature it was 56 Fahrenheit. So we had to replace it in this equation. So we have now 56 equal to 70 negative 60 multiply the exponent negative k 3 times 3. Now, our objective is to find the k, this k here. So in order to find this k, we have to keep along the most possible this area from here. So doing algebraic operations, we will get the following. We will get 7 over 30 equal to exponent negative 3k. So what we can do in order to leave the k as a coefficient, as a normal term, we can do it by multiply by the logarithm. So in other words, the log, not the natural log. So we can cancel the exponent here. But in order to do this, we have to multiply in both sides. So we have the following. Okay, now we have to uh, cancel the exponent with the logarithm a. So we have now the following equation. Now we can move the negative 3 to the other side by dividing them in both sides. And now we have the following. Okay, equal to, because we have a negative here and it works like uh how we say it? It works like a -1 in the front of the length, and whatever is in front of the length, it can convert to exponent inside of the lateral log. So in other words, uh, this negative represent the following, which is equal to 30/7. So we have now the following equation equivalent to the k. Okay, now that we find the k, we have to find the real question from the text, which is what is the temperature of the 12 p.m. And we can solve it from our second initial values, which is the from the 3 from the 12 3 p.m. to 5 to the 12 5 p.m. We have a difference of 2 minutes. So this will be our new 3, our new value for the time, and our new value for the temperature will be 56 degrees, because this is the last change on temperature for the thermometer, and our new temperature and environment will be 5, because after the change in the temperature, the thermometer will move it to an environment or to a room of 5 degrees. Before, what was the 70 degrees, now it's 5. So we had the following equation. And the value of k times the time. So in a complete equation will be the following. And we can now put this in our calculator, but we can simplify it as well. It will be the same. So I would say that this is the perfect or the exact uh, answer, because the calculator will be a decimal value, so I don't know if it's required to simplify an exact answer, or just to put it at a decimal. So an equivalent from this value will be 24.33 Fahrenheit degrees. So this will be the answer after 2 minutes before from the last change in temperature. Thanks for listening.